Bismillahirrahmanirrahim. In today's lecture, we are going to study equations which are not quadratic, but they can be reduced to quadratic equations. Okay, so these equations will not be quadratic, but we will be able to transform it into quadratic with the help of a few calculations that we are going to learn. And there are a few types which is included in your syllabus. The first type type 1 is of that when suppose you have an equation and there are two expressions. Okay, and if one expression is the square of the other. Okay, in type 1 we are going to learn those equations in which there will be involving two terms, and one will be the square of the other. One expression will be the square of the other. Okay, for example, let me write a few examples from your exercise. First is 2x raised to power 4 minus 11x square plus 5 is equal to 0. The second example is 5x raised to power 1 by 2 is equal to 7x raised to power 1 by 4 minus 2. Third example is x raised to power 2 by 3 plus 54 is equal to 15 x raised to power 1 by 3. And the fourth is 3x raised to power negative 2 plus 5 is equal to 8 x raised to power negative 1. Now, as you may see, if I square this expression, I get this. Okay, so it means it belongs to this type. This is an equation which is not quadratic, because in quadratic the degree or the highest the degree of the polynomial was 2, but over here the degree of the polynomial is 4. So this is an equation which is not quadratic, but we will transform it into quadratic expression. Okay, because in this this is of type 1, in which one expression will be the square of the other. Okay, over here if we square x, we have two expression. If we take the square of x square, okay, if we take it square, we are getting x raised to power 4. So square of this number is equal to this. Similarly, if I take the square of this number, I will get this, because x raised to power 1 by 4, if I take the square of this expression, what do we have? This will be equal to x raised to power 1 by 4 into 2, which is equal to x raised to power 1 over 2, because this 2 will cancel out 4 by 2, and we are going to get this. So if we square this number, we are getting this expression. Similarly, if you look at here, x raised to power 1 by 3. Now if we take the square of this expression, what will happen? This will be x raised to power 1 by 3 into 2, which is equal to x raised to power 2 by 3. So taking square of this number, we are getting this expression. Similarly, if I take square of x raised to power negative 1, okay, this is the expression. If I take the square of negative 1, we will get x raised to power negative 1 into 2 will be negative 2. So if I square this number, I am getting this number. So if you have these type of equation, you can use the method that I am going to tell you how to do. This will be these all equations are of type 1, in which one expression is the square of the other. Now, in order to solve such expression, if you have such equation, for example, this is not quadratic, this is not quadratic, any one of these is not a quadratic. All of these four are the equations which are not quadratic, but we can easily reduce them to quadratic by making some substitutions that I am going to tell you. Okay, x raised to power 1 by 3, its square was x raised to power 1 by 3 into 2, which is x raised to power 2 by 3. So when we took the square of this number, we got this. Similarly, when we took the square of x raised to power negative 1 square, we got x raised to power negative 2. So these are all of type 1 equations. Now let us do a few examples, one of these two examples. Okay, the first question that I'm going to do is two x raised to power 4 minus 11 x square plus 5 is equal to 0. Okay, this is the first equation of the exercise, and this is of type 1 because we know that if I square this expression, I get this one. Okay, so now the method of solving such equation is that what you are going to do is you are going to pick this expression, okay, the one which is the square root, the one which is having the less degree, okay, that will be the square root. What you are going to do is you are going to pick this expression and suppose it to be equal to y. Okay, you are going to pick this expression and give it the name of y. Okay, y or z or any variable that you like, but give it a name. Okay, and then what you are going to do is you are going to replace this x square with the expression of y, and over here also you are going to replace all the expressions which are involving x by y. Okay, for example, if y is equal to x square, then if I take the square of both the sides, then what will I get is y square is equal to x raised to power 4. So what you are going to do is you are going to put this expression and this expression in the given equation. Okay, so what you are going to do is the expression which is the square root, okay, the expression which is having the less degree, you are going to take it equal to some y or x. Okay, and then you are going to derive an expression in y for this expression also. And how you are going to derive? We know that x, if I square both these sides, then I will get x raised to power 4. So I squared them, and we got y square is equal to x raised to power 4. So what you are going to do is put y is equal to x square and y square is equal to x raised to power 4 in equation 1. Let it be equal to equation 1. Okay, so so that this whole equation is in variable y. Okay, there should be just one variable, and that is y after substitution. So let us start. This will be 2, and x raised to power 4 is equal to y square. So this will be 2y square minus 11y plus 5 is equal to 0. Now as you may see, this equation is now a quadratic equation. Okay, so by substitution, by making these steps, I have reduced this equation which was not quadratic into a quadratic, into the form of a quadratic equation. Okay, now I'm going to solve. After transforming this into quadratic, now we are able to solve this equation. Okay, you can solve it by any method you like. Okay, by factorization or by quadratic formula or by completing square. Now if I solve it by factorization, then I will need two numbers whose product is equal to 10 and whose sum is equal to negative 11 and whose product is equal to 10. Okay, so the two numbers whose product is equal to 10 and whose sum is equal to negative 11 are negative 1 and negative 10, because their product is positive 10, and because we want negative 11, so we will have to put negative sign with both the numbers so that we get negative 11. So I am using the midterm breaking method, okay, to solve this equation. Okay, solving this equation, I have split I have broke the midterm. I have into I have written the midterm as a sum of these two numbers that we got in this step, and then taking 2y common from the first two, as we usually do. Taking negative sign from here will revert the sign inside the bracket, so we will get y minus 5 common. Now solving these again by using the factor theorem that we did in the previous lectures. Either y minus 5 is equal to 0 or 2y minus 1 is equal to 0. It means either y is equal to 5 or y is equal to 1 by 2. So we got two equations of y, but you know that this was not our real equation. We had to solve this equation, and for that we had to find the values of x, which is making this expression 2. But we have found the solution of this equation, and with the help of the solution of this equation we are going to find the solution of this equation by using this expression, because we know the relation between y and x. If you know y, you can easily get x by taking the square root of y. So let me write these two. Y was 5 and 1 by 2. Okay. Now we know that according to our definition y was equal to x square. Now the answer that we got for y was y is equal to 5 and y is equal to 1 by 2. Okay, these were the two values that we got. Now to get the values of x that we require for this equation, we are going to use this equation. Okay, we know that y is equal to x square. So if we want to find x, what we are going to do, we are going to take the square root of y. So putting the value of y in this equation one by one, first I am going to put the value of y to be equal to 5 in this equation, which will be 5 is equal to x square. In order to get x, I will take the square root of both sides and it will come out to be equal to under root 5. So x has two values over here, and again putting the value of y from this expression into this expression, what we are going to get is 1 by 2 is equal to x square. Now taking square root of both the side, first you can write it like this, or you can take the square root directly. Okay, this will be 1 by 2, which is equal to plus minus 1 over under root 2. So now we got the values of x, which are the solutions of this x equation, which was not quadratic, but we reduced it to quadratic expression. So the solution set will be plus minus under root 5 and plus minus under root, or let us write it as 1 over under root 2. So this will be our solution set. The equation was not quadratic, but we transformed it into quadratic, which helped us to get to the equation, because once it was transformed, it was quadratic in the variable y. Okay, and as it is transformed in y, we got a quadratic equation in y, and we solved it for the value of y. We got two equations. After obtaining the value of y, we could easily reach x through this equation. So this is how you solve the equations which are of type 1. Okay, and let me do one more example, and then you try the rest of them, and do let me know if you have any problem. Another question in your exercise was that of question was 3. Was question number, I think 5, maybe 3 x raised to power negative 2 plus 5 is equal to 8 x raised to power negative 1. This is the question, and as you may see, if I square this x raised to power negative 1, I will get x raised to the power negative 2. Okay, squaring this will give us this. So what am I going to do is I am going to do the substitution and substitute it to be equal to y. Okay, the square root. So let y to be equal to x raised to the power negative 1. Now again, to get this expression I will have to take square of this. Okay, so I am going to take the square of both the sides, and I will get y square is equal to x raised to the power negative 1 whole square, which is equal to x raised to the power negative 2. So y square is equal to x raised to the power negative 2. So what am I going to do is I am going to replace this expression and this expression and convert this whole expression into y, which will give me a quadratic expression. Okay, so when I replace this and this, what we get is 3 x raised to the power negative 2 is equal to y square. I am going to put y square in place of this. Okay, because these two objects are same, so can easily be replaced. Okay, a and y. Now what am I going to do next is we got a quadratic expression, but it is not in standard form, so I am going to write this expression into its standard form. Okay, now can we solve it by factorization? We know that 3 into 5 is equal to 15. So can we get two numbers whose product is equal to 15 and whose sum will give us negative 8? We know that 3 into 5 are 15, but we want negative 8, so 3 plus 5 is positive 8, so I am going to put negative sign with both these. Okay, so that we can get a negative 8. So these are the two pairs that we require. So I am going to write the midterm as a sum of these two terms, and again I am using the method of factorization that we have already done. Okay. So solving these two, we are going to get y is equal to 1 and y is equal to, by shifting 5 to the right hand side and then dividing by 3, we are going to get two values of y, which are, so y has the solution set. Y has two values, 1 and 5 by 3. Okay, now I got the values of y. With the help of these two values I am going to get to the values of x by using this equation. So we had two values of y is equal to 1 and y is equal to 5 by 3. Okay, if y is equal to 1, then using this expression what we will have, put the value of y over here. This will be 1 is equal to x raised to the power minus 1. As we want the value of x to solve this equation, so we have to find the values of x from here. We know that x raised to the power minus 1 can be written as 1 over x. So taking reciprocal of both the sides, or taking cross multiplication in any way you want to think, x1 will be equal to x, because reciprocal of 1 is 1, so x will have the value of 1. Now similarly we know that y is equal to 5 by 3, so putting the value of y in this expression, we will get 5 over 3 is equal to x raised to the power minus 1. We can write x as 1 over x. Okay, by the rules that we have, the rules of exponent that we have learned, we know that a raised to the power negative n can be written as a 1 over a raised to the power n. This exponent gets positive when we change its place from denominator to numerator or numerator to denominator. Now if you do the cross multiplication, this will be 5x is equal to 3, and we can find the value of x from here. Or you can also take the reciprocal directly, which will also give you the value of x. So it means that our solution set will be 1 3 by 5. Okay, so this is how we solve the equation of this type. All we have to look for is, if you have two expressions, just square one and just check whether it is the whether we get an expression which is equal to the second one, this one. Okay, if we square this, we get this one. So square the expression which has the degree which is numerically less. Okay, and then if it's so, it means type 1, and this is how you solve the type 1 equations.